Jake. 6 terms. No, splitting the middle is only for 3 terms. Maybe we should do that. If there are 2 terms, we have to look for special patterns, which could be the difference of perfect squares, the difference of perfect cubes, or the sum of perfect cubes. Those are our 2-term special patterns. If it's 3 terms, there's one of 2 methods. Both will work. Guess and check. Or split the middle. And if there are 4 terms, 4 plus terms, so 4 or more, we use grouping. Now with 5 terms, you can't really group, right? It has to be 2 by 2 by 2 or 3 by 3, 4 by 4. It cannot be, you can't have an odd number of terms. Lydia? So, yeah, this never came up yesterday in this class, but it did come up in my other class when we did this example on yesterday's notes. And the first thing someone said there was combine like terms. Now, if you combine like terms, and just watch for a second, k to the 4th plus 8k squared. Oh no, plus 8k cubed first. Then the plus 8k squared minus 32k minus 48. If you combine like terms, now you've kind of done yourself in, unfortunately. We actually had the same thought when we first saw a question like this on the Regents last year. And we were thinking, well, that's pretty nasty because you've been trained from day 1 to combine like terms and simplify things, right? So we can't really blame you, but now there are 5 terms, and now we have no idea how to tell you to do this. You can't really factor it from here. So they actually leave these 2 terms separate by design so that grouping will work. So here's my rule to you, my instruction to you. If the instructions are to factor, do not combine like terms. Factoring and combining like terms and simplifying are opposite. So factoring deserves to be called the complete opposite of simplifying. Simplifying is distributing and combining like terms. When in reality, when we factor, particularly when we split the middle term, we are uncombining like terms. And then we are factoring and undistributing. So we're doing the opposite of that. So I know that that's your instinct, but when the instructions are to factor, resist that temptation. And so we, with 6 terms, need to try 2 by 2 by 2 or 3 by 3. So I will try, what do you want to try first, Aiden? Pick 2 by 2 or 3 by 3. Okay, so if we try 3 by 3, and we may have to go back and erase this. Is there a GCF, Aiden, in my first 3 terms? If so, what is it? Just t. Perfect. So we take out a t, we're left with t squared plus 5t plus 6. And then what do I take out of my second grouping? Cameron? What's that? You can't, but in grouping, if you can't, what do you take out by default? 1 plus 1. So, did that grouping work? Do my sets of parentheses match? Yes, so it did work. So if I compare these 2 sets of parentheses now, or I take that out as a GCF, the GCF I'm taking out in front is t squared plus 5t plus 6, and then I'm left with t plus 1. How can you make sure, on a side note, that you don't get your T's and your plus signs confused, Andrew? A little curve at the bottom will help prevent that mistake. So you'll notice that math people do that, because there's nothing more annoying than getting the wrong answer and realizing it's because you thought your plus sign was a T or your T was a plus. So that's how we prevent it. Now, can either of those two factors be factored further is the question you have to constantly ask yourself. What do you think, Madeline? Which one? Good, yeah, it's worth a try. So for a quick check, like rather than guessing and checking when it's not possible, you can do a quick check to see if it is possible. You would need two numbers that multiply to get 6 and add to get 5. Do they exist? What multiplies to get 6 and adds to get 5? 2 and 3. So it is possible. Now, if you want to use those two numbers and split the middle term, you can. I tend to think that this one is easy enough to do by guessing and checking. We have a T and a T. It has to be a plus and a plus. And then the 2 and the 3 are actually the two numbers that will work. And then, of course, you have the T plus 1. So this has now, this polynomial, the original polynomial, has factored into 3 factors. And that's your final answer. Any questions on that? Okay. So yesterday, I believe when we did this one, the 3 by 3 did not work, and it had to be done 2 by 2 by 2. So you've seen different, one of each type. When you look at number 2, what do you notice? The same parentheses, right? X plus 2 is being squared, then x plus 2 is being multiplied by 2. So like we did yesterday, we're going to kind of use our own symbol system here. We're going to let y equal that x plus 2, so that we can rewrite this as y squared plus 2y minus 8. And now, isn't this easier to factor? So a quick guess and check on this will give us y and y. And then what are my two numbers? What do you think, John? Minus 4 plus 2. Do we agree? Raise your hand if you disagree. What should it be, Jordan? Plus 2 minus 4? That would be the same thing he just said. First of all, let's talk about why this does not work. Your outer gives you plus 2y, and your inner gives you minus 4y. What's a positive 2y combined with a negative 4y? Negative 2y, and we wanted positive 2y. So we really just need to switch our signs. Should be a plus 4 and a minus 2. Does that make sense? So be careful that you check. You actually guess and check. Really, really does require that you check. From here, remember we only had x's to start. So now that it's partially factored, and really this is factored as far as it can go, we now need to take our y's back out and replace them with the x plus 2's. So that's x plus 2 plus 4 and x plus 2 minus 2. And then this simplifies to x plus 6 and x. Any questions on that? Number 3. Take a look at that. Tell me what we're going to do first. Evan? Which is m, take out an m, very good. So we have m to the 4th plus m squared minus 6. And so the 3 terms that are left, our method is either guess and check or split the middle. Now, let's actually guess and check on this one, because there's an interesting, we just haven't talked about guessing and checking on this type of problem yet, because the first term is m to the 4th, right? And what times what gives you m to the 4th? M squared times m squared, and it has to be. In some areas, it could be m to the 3rd times m, but the middle term should always be half the degree of the first term. So if this has a degree of 4, an exponent of 4, the middle term is half of that, 2. And so that's what's going to create m squared terms on the outer and m squared terms on the inner, so that they combine to be m squared terms in the middle. And then to get negative 6, you have a couple options, 6 and 1, 2 and 3. Because this is a positive 1 in the middle, I'm going to do positive 3, negative 2. See, I picked the 3 and 2 because they had a difference of 1. And I put the plus sign with the bigger of the 2 because I wanted the outer and the inner to balance off to be a positive. So the double check here, minus 2m squared plus 3m squared gives me that. Can any of those factors be factored further? Andrew? Why? So this 2-term thing, are you thinking it's the difference of perfect squares, difference of perfect cubes, or the sum of perfect cubes? Neither, right? So it's actually not. If it was m squared minus 4, we'd be in luck. But it's not a perfect square, so we're done here. So when you're doing these, there's the trick that sometimes people don't go far enough. That happens a lot. And sometimes people go too far and they do things that you can't do. So you want to make sure that we're really clear on what we're looking for. And the last one here. First step. Kaylee M, what do you think? GCF, what is it? 2D, good. And so we're left with 4 terms. And Kaylee Smith, what's our technique with 4 terms? Grouping, yeah. So if I group the first 2, what can I take out? Kirsten? D squared, and left with a what? Good. And in my second group, I can take out what, Nathan Henry? Minus 9, and I'm left with? Good. So did grouping work? Yes. And what are my 2 terms, Isaiah? Good. And then which one of these can be factored further? Yep, difference of perfect squares. So I have this d plus 3. And then my difference of perfect squares gets its own set of, what's the vocab word? Conjugates, d plus 3, d minus 3. This is not my final answer. I could do 2. I have to do one more thing. I could do a second thing as well. What are you thinking, Nate? Absolutely. Do not forget about that GCF. That has to be brought down. And then Lydia? Right, since I have 2 of those, the most efficient way of writing it would be with a squared. Perfect. Any questions on those? Okay, couple things. Number one, we have to finish this example from yesterday. Because I do want to do it. Actually, we didn't finish the last two. So let me pick up here. Yeah. So we just did another one like this on today's notes. But I want to pick up where we left off yesterday here. So the 4x squared plus 5x was the same in both cases, so we let it be y momentarily so that we could factor it, and then we bring our y's back to what they were. Now each of these trinomials is potentially able to be factored further. Now I would probably not guess and check, just because it could be 1 and 4 or 2 and 2. Then you've got 1 and 6, 6 and 1, 2 and 3, 3 and 2 with all your plus and minuses. Way too many guessing, right? So instead, I would try to split the middle on this one first. I need two numbers that multiply to be what, Aiden? Two numbers that multiply if I'm splitting the middle. Yep, negative 24. And they need to add to be 5. Someone tell me what they are. Multiply to get negative 24 combined to be 5. McKenna. Positive 8, negative 3. Good. So they exist. So this is factorable, and I'll just do it right under here. 4x squared plus 8x minus 3x minus 6. Just go through my grouping. You guys can do that on your own. So rather than all that guessing and checking, I can now convincingly put down my two factors, 4x minus 3 and x plus 2. On my second trinomial here, I would need two numbers that multiply to get what, John? 4 and add to get, do you know what they are? Very good. So again, 4x squared plus 4x plus 1x plus 1. Go ahead and group from there. And again, I avoid guessing and checking. Although that one would have been at least easier to guess and check because it had to be 1 and 1 on that last term. So that one wasn't bad. But this ends up factoring into 4 factors. Any questions on that? Okay. Going back to this proof. This is a proof, although they're not writing the equation for us, so we have to come up with it on our own from the words. So we want to prove that the difference of the squares of any two consecutive integers is, so we'll pause there because the word is usually an equal sign. So first of all, talking about consecutive integers. How do you define two consecutive integers? Definitely something you did in Algebra 1. First, you got to make up your own variable, right? So your first integer is going to be x. What's the next consecutive integer from x? How do you get to the next consecutive integer? Oh boy, crickets. Cameron. If I tell you the number 7, what's the next consecutive integer from 7? 8. How'd you get there? Just one more. So good, perfect. So how do you write one more than x? X plus 1. So there's your first integer, and there's the next consecutive integer. So let's first of all make sure we can identify that consecutive. So we want to prove that the difference of their squares. So here's the square of the first one, just x squared. The difference, here's the second one's squared. So there's the difference of two consecutive integers squared. Does that make sense? Okay. We want to show that that is, so is means equals, an odd integer, which we'll get to in a second. I'm just going to write that that equals an odd integer. So if I go to simplify this out, x squared is just x squared minus, when I square this, I had to keep it all in parentheses, that's going to be x plus 1 times x plus 1. Then I can FOIL it out, but I got to keep the whole thing in parentheses because I eventually am going to have to subtract the whole thing. So I have x squared plus 1x plus another 1x plus 1. Right? With any proof, you simplify the left, simplify the right. So we're simplifying the left right now. I'm distributing my minus sign. So it's going to be x squared minus 1x minus 1x minus 1. And that's all going to, well, the x squared minus x squared is going to cancel. The minus 1x and minus 1x are going to become negative 2x minus 1 equals an odd. Now from here, I think the rest of the proof has to be more or less an explanation. No matter what x is, explain why this has to be an odd number. No matter what integer x is, why does that have to be odd? Go ahead, Cameron. If you plug in any number for x, I think you missed a part. If I take any number for x, but you're not going to subtract 1 right away, what are you going to do to it right away? Multiply it by 2. Nathan, tell me what you're going to say. Perfect. Okay? You could just say that you're essentially multiplying any number by 2. Any number you multiply by 2 is going to be even, right? It's a negative 2, but whether it's negative or positive, it's still even when you double something, right? So if you double it first and make it even, then any even number, when you subtract 1 from it, becomes odd, because that's the nature of our number system. It goes every other, even, odd, even, odd, even, odd. So if we double something, so if a number is doubled, it is even. Then if you subtract 1, it becomes odd. That proof was a Regents question. You had to write your own stuff for kind of the description. Then you had to simplify the left. There really is no simplifying the right, and then an explanation, which is an interesting twist on a proof. Your homework tonight are these 10. The answer key, though, is wrong for number 1. Number 1, and you'll see it right away, it says 2k plus 1, 2k minus 1 on the bottom. It's really 2k plus 3 and 2k minus 3. So just fix that, and then those 10 questions are your homework. Factoring, we're closing up shop on factoring. We kind of have hit it all, so you'll have a quiz on Friday.